So we're moving into 2.3 in Math 098, and I'm confident you guys are good with graphing linear functions, but it's something I need to do. And again, you're probably familiar with the y equals mx plus b, where b is your y-intercept, and your slope, your m, is your rise over run. So as we look at this, I'm going to graph f of x first, because if there's no plus number over here, that's just crossing at the origin, which makes perfect sense, because if x is 0, then y is 0. I know it's in function notation, but if you remember from a previous class, they said f of x is just equal to y. So anyway, the slope is up 4, right 1. And we just need 2 points to make our line, connect those dots. It looks something like this. It would be nice if you could clearly show your point and then plot that ordered pair. Unfortunately, I did not give myself much room here, so let me go ahead and erase this 0, 0, because I want to do g of x in a different color, and it's shifted down 3. So down 3 is your y-intercept, and that slope is still up 1, 2, 3, 4 over 1. So as you look at this graph, it's pretty much the same, except the graph of g of x is the same as f of x, except it's shifted or translated. You might use that word. I just use the word shifted down 3 units. That's the only thing that's different there. So as we move on to exercise 3, we also talk about finding and plotting intercepts. And you can use a graphing calculator to do this. Desmos is perfect, if you want to. I'm not going to go to it because it's just going to take more time, and I think we're good so far. And if you're doing plotting intercepts, sometimes what I do is I tell students just cover up. So I'm going to cover this up, and then I'll show it again in a second. And what you're left with is an equation, x equals 6, that when you solve will give you the x-intercept. Well, there's nothing to solve there, so this x-intercept is 6. And you might be saying, well, how does this work? Well, this works because the x-intercept is the value for x when the other value is 0. And that's why covering it up works, because if y is 0, well, anything times 0 is 0, so x has to be 6. I can do the same thing for covering up x, and I'm left with negative 3y is equal to 6, and divide by negative 3 to find out that the y-intercept is equal to negative 2. Negative 2. So again, why does this work? Is the x value is 0, the y value is negative 2. Well, if x is 0, well, 0 minus 3 times negative 2, that's negative 3 times negative 2 is positive 6. So I don't want that left there. But we have our 2 points. We only need 2 points to make a line. So yeah, we're good to move on. Exercise 5 is more of the same premise that I actually like leaving my slope as a ratio, but I've seen some students that just need to see that like decimal, and I'm fine with this because when you go to the graph, let me scroll down a little bit, give myself some more room. Whoops, I guess when I scroll it ruins that. Fix that real quick. So if you're labeling then, like call this negative 1, it might help me see that you understood that that slope or the y-intercept went down 2/5 of the way or down 0.4. So then from there, it'd be nice if you also labeled some of these other things. If you still go up 3, right 4, you might want to count from this point up 3, right 4. And now I'm kind of getting way up here. So it'd be 1, 2, 3. Sorry, my graph. I should have planned this better. I did want to point out, though, is if it makes more sense to you, you could go up 0.75, right 1, up 0.75, right 1, up 0.75, right 1. And what you'll end up noticing is this decimal still works, is that if I go up 3, right 4, I just have way more than 2 points to make a line, something like that. I think they're just throwing in decimals to try and make this more confusing for you, but we're better than that. Sorry, the bell keeps ringing. Anyway, so my y-intercept is 4.1. I made a terrible x-axis, but you can forgive me. So it's about right there. And then 5, 6, 7. So up 2.6, right 1. So from this point, about 1, 2, and a little bit more, and then right 1. I'll just put it like right there. I think this is my right 1. Notice though that I do expect to see, an x-axis, a y-axis, and labels. Because what I don't want to see, you just do this. And I saw this over and over again from a previous class, and it bugged the heck out of me because you're not distinguishing which one is 4.1 and which one's 2.6. Even if your graph is off a little bit, it's evident to me that whoever drew this, I know it was me, could tell that the y-intercept was bigger than 4. So that individual was not confusing these numbers. And that the slope was 2.6. Even though I might not have a perfect graph, I'm definitely not an artist. It's clear that I know what I'm doing. So that's what I need to see from you. Here's a few more. They're asking you to plot intercepts. The reason why they're asking you to plot intercepts on this one is because if you were to do the intercepts, well, plug in 0 for x and you're going to get 0 for y. Well, that's an issue, okay, because we only have 1 point. Like, where's the other one? So can you plot intercepts every single time and come up with a graph? No, because we need 2 points to make a line. But we're better than this. We know that this is just the slope, so it's down 3, right 1. Connect those dots. So the reason why the book asks you to do exercise 6 this way is for you to realize that plotting intercepts does not always work. Sometimes you need a new method. As we move on to the next one, just a reminder, if you ever have x equals, this is a vertical line. Another way to think of this is, okay, I'm going to graph my x and y axis. Where is x equal -4? Well, it's over here. Okay, well, we have to have a vertical line here. And if you're confused why x equals is a vertical line, well, look at all these ordered pairs. Okay, well, this ordered pair maybe is -4, 0. Maybe this ordered pair, I'm just making up numbers, is -4, 8. This value, -4, I don't know, -5. I'm just making things up. But what's the one thing that's the same for all of these ordered pairs is the x value is the same. That's why vertical lines are written like this. You may be thinking about how the slope, what's the slope of vertical lines? Undefined slopes. Okay, it's not in slope-intercept form, so it's got to be something else. Which you could say the same thing about y equals. I'm not going to do nearly as much, but I am going to point out another way of doing this. So y equals 3 is a horizontal line. And I would ask you, well, what's the slope of this? I'm going to write m for slope. Now the slope is 0. And you might be saying, why? This one was undefined. Why is this one defined and it's 0? Well, let's think of it. This you could write as slope-intercept form as 0x plus 3. If you're not convinced, well, what's 0 times anything? Still 0, and add 3 to it, you get 3. So we can definitely write this in slope-intercept form. That's why we have this value. Everything in math is beautiful. Just one more problem that I want to cover before assigning the homework. Here's your homework. All right, odds 31 through 69. They give you this equation. It's a linear function telling you that x is the number of miles driven and c of x is the cost. All right, so no matter what, it costs $79 and then 10 cents per mile driven. So what you could do using function notation is just plug in 50 into all of these, but I'm going to use Desmos. Desmos is my friend, if you can't tell. So just typing in here, y equals 79 plus 0.1x. And instead of looking at the table and seeing when x is 50, instead of looking at the graph and seeing when x equals 50 and trying to approximate, even though that's exactly 84, I can create a table, hit that wheel, hit that thing, just right here, and change your numbers to 50. So the y costs $84 to go 50 miles. All right, and then the next one I'm going to change to 175. Costs $96.50. Saves you a lot of time to do this. Also notice that this is a linear equation. If you look, it's a straight line. It was 230, wasn't it? Nope, I accidentally mixed that up. 102 there. And the last one, 450. $124 that one. There you go. So use Desmos anytime you can. It's internet based. You can use it anywhere as long as you have an internet connection. And there's your assignment. Enjoy.